Welcome to 10.1 Right Triangle Applications Day 2. Again, still reviewing, my friends. We're still reviewing, then we'll get to new stuff. So it's important to remember these two formulas. So the first one is area of a right triangle. Notice it has to be a right triangle, then it can follow this formula right here. If it is just any triangle, so it could be acute, scalene, obtuse, like literally any kind of triangle, you have this formula. AB sine of theta. Again, this should not be new, but this would be a nice review. Know that the angle here, this theta, has to be the angle in between side lengths A and B. Okay, let's do a couple examples and I think you'll get the hang of it. So looking here, find the area of the following triangle. Well, we need to ask ourselves, is this a right triangle? Well, it's not, because I don't have a 90 degree. So now I'm going to use my second option, which is area equals 1/2 side length times sine of my angle of focus, or the angle I'm given. Well, I know this is a side, this is a side. It doesn't matter which one you call A or B. So I'm going to go ahead and just write 1/2. A is going to be 3. B will be 12. And sine of 60 degrees. So as I simplify, I would get 18. I know that sine of 60 is root 3 over 2. So my final area would be 9 root 3, which is approximately 15.59 centimeters squared. Okay, so the first answer is what we call exact. So if it said find the exact area, you would give us 9 root 3 centimeters squared. If it said approximate, you can give us the 15.59. Okay, again, this is old, finding the area of a regular polygon. This time I'm going to challenge us to use the area of any triangle. In the cases that we see in Chapter 10, normally that will make it easier versus finding the right triangles within the picture. If you want to keep doing what we did last time, go for it. This is just another way to look at it. So what you need to first see is how many sides is in my regular polygon. Well, here's 1, 2, 3, 4, 5. So I have 5 sides. It is a pentagon, which means you have to realize that the whole circle is 360 divided into 5 different triangles. So this is one triangle here, we have another triangle here, and we keep going. Now for the sake of this, I'm just going to show the one triangle so we don't get confused. But that's what we're looking for, okay? We're going to divide it into those 5 triangles. So I have 360 degrees is a full circle. Divided into your 5 triangles, that gives each angle right here, each theta, to be 72 degrees. Okay, so we've done this before. That equals 72 degrees. Well, if I can find the area of that shaded triangle, then multiply it by 5, I just found that area of that regular polygon. So let me go back, review my triangles. It's not a right triangle, so I need to use my formula, area equals 1/2 AB sine of theta. Okay, well, I know the side lengths are actually the same. They're both 2 and 2. I'm just going to plug them in order, doesn't matter, obviously. And then sine of 72 degrees. Now, sine of 72 is not going to be perfect, so it's okay that this answer is going to be a decimal. So the area and I'm going to make this clear, of my one shaded triangle is about 1.90. Okay, so that is just that one shaded triangle. Well, I want the area of the entire thing. So like I mentioned, I'm going to multiply it by 5 triangles, each being 1.9 inches squared to get my total of the whole polygon. So 1.90 times 5 makes the area of the entire shape about 9.51 inches squared. Okay. If you want to try this one doing area of right triangles, just make sure you cut your 72 degrees in half. I'll show you what that would look like. You would cut it in half here, have this right angle, and then you would do 1/2 base times height. You will need to do trig in order to get the height, and then you can go around with SOHCAHTOA to find your base. Okay, so a little bit longer, but if you want to give it a shot, go for it. Then finally something new, finding the area of a segment of a circle. So the segment of the circle is the region bounded by an arc of a circle and its chord. Compute the area of a segment, aka the shaded region, in figure 6, which is shown below. Give 2 forms for the answer, an exact expression involving pi, and a calculator approximate rounded to 2 decimals. So like what I mentioned before, if it says exact, you normally leave the pi, the square root, or if it wants approximate, you can use your calculator and simplify to the nearest decimal. So the main thing I'm finding, like it said, is that blue shaded region. So there's a nice formula that we can follow from there. Area of a segment will equal the area of the sector minus the area of that triangle. So what I'm going to first do is find the entire thing, this whole piece, area of sector, and subtract away the shape we know. And I definitely can find the area of a triangle. So once I take that out of it, I'm left with the blue shaded area. Okay, so a couple formulas for you. Area of a sector, 1/2 r squared theta. Very, very similar to 1/2 AB sine theta, which I'll talk about in a moment. But here is the formula. Actually, disregard what I just said. Don't think of it that way. I don't like that way. Nope. So there's the area of a sector. And then here, is the area of a triangle. 1/2 AB sine of theta. That's what I wanted. So one huge important thing to note, these thetas need to be in radian. Super, super important. Okay, you cannot put a degree in, otherwise your answers will be really, really messed up. So make sure your angles are in radian. So let's just kind of plug in and see where it takes us. So we're going to start with the area of the sector, so that's that green piece of the pie. The area is going to equal 1/2. My radius is 2 squared, and luckily my degree is already in radian, so 3 pi over 5. Okay, that's going to simplify to 6 pi over 5. Just multiply across. Erase that 5, make it pretty. And that is the area of the sector. Now I need to take away the yellow triangle. So area 1/2. Again, this is not a right triangle, so this is why I need to use 1/2 AB sine theta. A is 2, B is 2, and then its sine, again, it needs to be in radian, 3 pi over 5. Okay, when you're done, that's going to simplify to 2 sine of 3 pi over 5. So those are my two pieces. So the first one asked me to find the exact answer. So that answer is going to look like this. The sector minus the triangle. And that is as simple as you need it to get. Don't worry about getting any further because they are not like terms. We don't have to go any further. Then the approximate answer, which means using the decimal, should be around 1.87 centimeters squared, and this should also be centimeters squared. Okay, so nothing really new. It just mentions a couple new formulas for you to find area of a segment, and then you should be good to go. Good luck.